This conference will now be recorded. This conference will now be recorded.
Okay, students, good morning to you all. Can you hear my voice?
Yes, audible, sir.
Yes, right. So, do you know, right, I'm going to handle in this semester for you electrical power transmission system. So in this class, I'm going to give overview on how the electrical power transmission system will be and what are the topics you are going to study, what are the information you are going to know that, right? And one more thing, this is our very important core subject. So if you want to attend that exams like GENCO, TRANSCO, SPTCL, you will get more questions from this subject. So I will give well explanation about each and every topic, and I will give guidance about how you can, what are the questions you will get in our upcoming exams and competitive exams like that. And in this class, I'm going to give that what are the syllabus you're going to study about in a electrical power transmission system, right? So I hope some of the students are going to join. So let them join. So we go for the class. So I have see this slide, electrical power transmission system. So till now you guys have studied about electrical power generation, right? What are the different methods we are going to generate the power, and what are the difficulties we faced while generating the power like that. And in this subject, you are going to know about how the generated power will be transmitted to the distribution system. So that is the intention of this subject. Now we'll see that one by one, what are the 5 units you're having in this syllabus. See here, these are the 5 units they have. One is the first unit is transmission line parameters. Second unit is performance of transmission lines. Third unit is mechanical design of transmission lines. And fourth unit is power system, transient and traveling waves. And last one is cables. So I will give explanation about what is the particular unit having the information. So let me go for one by one. So the first one is unit 1, that is transmission line parameters. So in this transmission line parameters, you are going to know that. So transmission line parameters in the sense, so already you know that electrical parameters, right? Resistance, inductance, capacitance. So these are the called as parameters. The same thing you are going to study about what is the resistance value, what is the inductance value, what is the capacitance value. We have to make that to conduct the transmission lines. So here, let me see that topic wise. The first one is types of conductors. See, these are the different types of conductors we are using in the transmission lines. So here, A is aluminum, all aluminum conductor, and triple S is all aluminum alloy conductor. Next, third one is aluminum conductor, alloy reinforced, aluminum conductor, steel reinforced, bundled and standard conductors. So this is the one of the important question you will get in semester exam. So what they will ask means explain about different types of conductors using in that transmission line system. So we have to explain all. Next, second topic is resistance for solid conductors. So in this, you had to find that resistance value of a conductor. Suppose, so do you know that if you know the value of voltage and current, you can easily calculate the resistance value by using R is equals to V by I. Similarly, if they want to design a conductor, they should know that what is the voltage capability of conductor. So based on that, maintain the resistance of a conductor. Next one is third one is skin effect. So skin effect in the sense, so this is the one of the major problem facing in the transmission system. So how it will be occurring, and what are the factors are affecting the skin effect, and what are the drawbacks we can obtain from this, and what is the remedies we can neglect the skin effect. We are going to you guys are going to study about in unit 1, that is transmission parameters. Next, fourth one is calculation of inductance for single phase and three phase, single and double circuit lines. So already second topic is resistance is over. Now you have to find out what is the inductance of a conductor, that is transmission line. And you are going to calculate for different types of lines. One is single phase, three phase and double circuit line, that is parallel lines. Next, concept of GMR and GMD. So this topic says that what is the distance between the two parallel lines. So if you see the transmission lines, if it is three phase means the three phase line transmission lines are going. So you should know that what is the difference, what is the distance between the two lines, right? So that concept we can, by knowing by GMR and GMD. Next is symmetrical and asymmetrical conductor configuration with and without transposition numerical problem. So symmetrical and asymmetrical means if the transmission lines are delivering the balanced load, then it is called as symmetrical. So balanced loads in the sense there is no step up and step down deviation. So suppose if the transmission line is sending it 400 kilovolts, the same thing will be delivered to the load. So that is called as symmetrical. It means that balanced. So balanced means the three phase should be phase angle is 120 degrees. Then only it is called as balanced. Asymmetrical means there is a phase deviation between the among the three phases, that is called as asymmetrical line. So these are the two topics you are going to study, and you are going to solve the different problems based on this topic. And next one is third parameter, that is capacitance calculations. And in the entire unit you are going to know about what are the parameters should be calculated for designing of transmission lines. So one is resistance, another one is inductance and capacitance. So in this unit, this is the one of the most important question. Already I said. Next one is second one, that is calculation of inductors. So it is a fully derivation part. We have different derivations for calculating the inductance. And next one is capacitance. So these are the three questions most for 90% you will get for semester exam, right? So this is the topics you are going to study in the first unit. Now, so you have idea about how the transmission lines should be looking like. So I will show you how it is. So let me see that. So already said that we are using in the different types of conductors in transmission lines. So these are the conductors and their structures like this. So the first one is all aluminum conductor. So this is the structure of this. So already you know that the conductor should be designed by different layers. After that, it should be wound up, right? So that is the thing. This is one, that is all wires are aluminum. So you get entire conductors of belongs to the aluminum. So that's it is called as AAC, all aluminum conductors. So you may get abbreviations also. So what is the abbreviation of AAC? What is the abbreviation of AAC, like that? And second one is AAC, that is all aluminum alloy conductor. So it should be like this. So if you observe this type, the center point diameter will be less when compared to the outer side. So it is completely belongs to the all aluminum alloy conductor. So it is not aluminum. So there is a belongs to the aluminum alloy. Next, third one is aluminum conductors alloyed reinforced. So most probably in present scenario, our transmission system using these two types. Why? Because these two belong to the reinforced. It means that its property should not change it based on the rain. Why? Because transmission line should be traveling in the environment condition, right? So it should be face rainy conditions. It should face temperature like that. So that's why we are using that these two types of conductors most probably, and that too based on the how much of voltage should be capable to carry that. And the third one is this aluminum conductor alloy reinforced. So here the aluminum wire should be inner side, the aluminum alloy should be outer side. This aluminum alloy should be is a reinforced material, so it should can withstand the rainwater. So it should not dust like that, right? And next one, fourth one is aluminum conductors steel reinforced. So what is the difference between aluminum alloy and the steel means, when compared to the steel, alloy should be bent, we can whatever it may be. So we can easily bend based on our requirement of shape. So that is the advantage of aluminum when compared to the steel. So these are the conductors we can use in the transmission lines. Now let me go for next one. So this is the different conductors based on the size. They are examined different types of animals. Suppose if the conductor size should be like this, the capacity of this when related to the torque, like that means how it will be going to run speeds. So it should completely depends based on the speed of run. So the based on, if you look at this, the based on size, the capacity of voltage should be increasing, and that travels speed also increasing, right? So these are the different four conductors based on their size. Let me go for how the, so what are the capacity of these four conductors? So this four conductors. So these are the four conductors we can use in different voltage levels like that. Suppose the first one is the conductor size should be less. So this type of conductor we can use for 33 and 66 kV. So the table completely says that if the conductor size will be increased, the capacity also increases. So and this is the name of, so it means that the based on the how much of speed it should be traversed. So that's why the animal name should be indicated here. And current carrying capacity at 75 degrees centigrade. So generally in India we are getting average temperature is 40 degrees centigrade. So we can, it can withstand up to 75 degrees centigrade. So that is that this type of conductor specialty. And based on the sizing and overall the diameter, so we'll go for a topic, we can see that one by one what is the voltage level of particular conductor, and what are the materials we are using, and what is the capacity of current carrying, like that we will see in the topic. So now this is the transmission line construction. See here. You guys have seen about the structure in the transmission line system. So in this subject, so just you are saying that you are thinking that this simply, but here there are major consideration will be capable here. Why? Because so if you see this transmission line structure, it has carries the three phases, 1, 2, 3, and so this is the parallel type conductors. So it is carrying the parallel supply, and he in this tower construction they should consider that what is the distance between the ground level to first phase, and what is the distance between the ground level to second phase and ground level to third phase, similarly between the two conductors. So these are the calculations they are going to study before the installation of this tower. After that they can install this. Now if you see these names, this is one is tower and the spacers. So there is no contact between the two faces. There is a one spacer is avoiding the distance between the two faces, and is the insulator, conductors, dampers, and cross arms. On top there is a wire that is called as earth wire. It is the most important question in competitive exam. So what they will ask means, what is the name of wire? It should be travels in the transmission line system. It should be over the all phases. So that is called as earth wire. So this earth wire should be protect the entire system from the lightning strokes and voltage surges and different types of faults occur in the transmission lines. Now we go for next slide. So this is the different names we are using in the transmission line system. The first one is conductors. You know that it is used for carrying the power from sending end to receiving end. And next one is supporters. Supporters are it's like towers, should be support the conductors and keep those suitable level above the ground. So it is very important topic. So it should be above the ground level. So if it is not ground level is properly, then it may hazard for the humans. So the vehicles is traveling under the transmission lines. Next one is insulators. So do you know what is the, so already you know that what is the insulator. So you should not allow the current through this and cross up. This provides support to the insulators. So these are the four terms we are using in the transmission line system. So next we see that second unit, that is performance of a transmission lines. So in first unit we design the transmission lines. Transmission lines. It means that what is the transmission line should have the resistance value, inductance value, and capacitance value. After designing that, we are establishing that. After that, we have to examine that how it will be performing. So that is called performance of transmission lines, that you are going to know about in the second unit. So in that, the topics are classification of transmission lines. So generally we have the three types of transmission lines based on the distance, based on the voltage levels, based on the voltage level carry. So that is called as short transmission line, medium, and long. So this is the one of the most important question from the second unit. So they will ask any one of these three. So explain about short transmission lines, explain about medium transmission line, and long. In that, the medium again is classified into two types. One is nominal T, nominal pi. It means that the structure should be in the form of T shape. Suppose if it is medium transmission line, some of the transmission line should be in this way. So this is the main feeder and it is the sub feeder. So this is the nominal T structure. If it is nominal pi means it should be like this. So this is the main feeder and these two are sub feeders. So these are the two types of transmission lines we will see in medium types transmission lines. So next one is mathematical solution of estimation of regulation and efficiency and all. So already you know that every electrical part we are going to study about what is the regulation and efficiency. Then only we can get idea about how it will be performing, right? So we are going to test about these three transmission lines, regulation as well as efficiency. Next one is long transmission line rigorous solution. So it means that, so the major, if the problem is occurred in the short and medium, we can easily rectify that. But in the case of long transmission line, it is highly impossible to rectify that. So in this topic, you are going to know that what are the remedies we can rectify the problems that was occurred in the long transmission line. And next one is evaluation of ABCD parameters. So already the same topic you guys have studied in the electrical circuits 2, that is two-port networks. So two-port networks in the sense, in here one port is acting as a source, another one is acting as a receiving end, that is load. The same thing here also in transmission line, one end is connected to the source, another one is connected to the load. So in that you are going to know or study about ABCD parameters and what is the relation among these four parameters. Next, interpretation of long line equations. It means that how we can use these ABCD parameters in terms of equations in the long line equation, that is long line transmission lines. Next one is surge impedance and surge impedance loading. So surge impedance, so this type of effect will be occur when the load is suddenly increased or suddenly decreased. So on that condition, how we can modify the surge impedance value. So that is the topic you are going to study. And next one is wavelength and velocity of propagation. So propagation in the sense how the voltage. So this transmission lines, some transmission belongs to AC and DC, right? So there is no problem in the DC transmission lines. Suppose if it is AC transmission lines, the voltage wave should be in sinusoidal. If there is any disturbance occurs, there is a change in the sinusoidal wave. So how we can change, how we can maintain this proper wave propagation in the waveform like that. Next one is Ferranti effect. So this is the second effect you are going to know in transmission system. The first one is skin effect. Next one is Ferranti effect. So Ferranti effect, in meaning of Ferranti effect means if the sending end power is less than the receiving end power. Suppose you are going to send them a sending end power is let consider it is 10 and if you are receiving at 12, it means that if the sending is less than the receiving end, then it is called as Ferranti effect. So this is the power you are going to sending in the from sending side, and this is the receiving. It means that you are going to receive the more power than the sending end. That is called as Ferranti effect. So when it will be happen means when the lightning strokes suddenly stroke on the transmission lines, that is the first reason. Next one is when the load is suddenly decreased. At that time you can get the Ferranti effect in the transmission lines. Next one is charging current and numerical problems. So charging current in the sense we are facing some special devices in the transmission lines for stabilizing the voltage. So how we can stabilize the voltage means by using the charging current. So in that you are going to know about what are the problems. You are going to do the numerical problems. It means that how much of voltage we have to stabilize that. So then only you can get that proper voltage at the receiving end. So these are the topics you are going to study in the second unit. So it is completely belongs to the performance. So how the first one is design, second one is performance. Now we'll go for next. So this is the structure of tower. So already said that. So here A, B, C is the three phases. In that you should have to calculate that what is the tower should be height from the ground level. So that is the first consideration. Next one is what is the let's consider it is R Y B. So it is R, it is Y, and it is B. So they have to calculate that what is the B phase level from the ground. So the distance between B phase and ground is F. So these are the standard values. It won't be changed. So these questions also you will get. So what is the three phase levels from the ground, like that they will ask. So it is one of the most important questions you will get in the competitive exams. So from ground level to B, it is 10.16 meters. From ground level to A, 6.93. So like that, they have to design that. And after that, here it is a bundle conductor. So in that, what is the distance between the? So already you see that four lines should be going like this. If there is a circle in that four lines, if you observe the transmission lines, you can get idea about this. So in that, what is the distance, minimum distance maintained between among the two neighbor conductors? So that is 0.5 meters. So that is called as quad bundle. So if it is four quad bundle, if it's two parallel bundles, if it is three tri bundles, like that, they will mention the names, right? So next slide is so this is the third unit. So after exam the performance, you have to provide the mechanical support to the transmission lines. So how we can support means, suppose if the transmission line should be like this means, so this is the tower 1 and tower 2. So in between that you are going to disconnect the transmission lines. In that, so if the transmission line is directly connected to the tower, it is act as a conductor. So it may cause electrical shocking. So how we can avoid this means by connecting the insulators, we can avoid this type of problem. So that is the importance of insulators. So in this unit, you are going to study about different types of insulators we are using in the transmission line systems as well as distribution system. If you are not using in the insulators, you are going to if you connect the transmission lines is directly to the tower will be get a shock. So this type of problems you can face in the rainy season. So if you in rainy season, if you touch the pole, you will get electricity shocking. So you can feel shocking, right? So that is the main reason. If the insulator is failure, you will get definitely you will get the shock. Similarly, in your house also, if you touch any wall, it will get shocked. So that is the because of insulation failure. If the insulator is failure, then the current will be passed through the everywhere. So that is the importance of insulator in transmission line system. Next one is string efficiency and methods of improvement. So what is the importance of string efficiency means? Suppose you are connecting the conductor between the two transmission lines through the insulator. Suppose if the conductor weight should be more and the insulator should capable to carry that conductor, so that is called as string efficiency. Suppose in summer season the conductor should be elongated. It means that it should be increasing its length. So at that time it should be capable to this lengthening of conductor. So that is given by the string efficiency of insulator. Next, capacitance grading. It means that what is the capacitance? It means the strength of the insulator. It should be known by the third topic, that is capacitance grading and the static steering. Next one is corona. So this is the third loss we are facing the transmission system. So what is the meaning of corona loss means? Suppose our transmission line should be traveling in the environmental condition. So it is completely metal. Already you guys are studying in the chemistry. If a metal is placed in the environmental condition, due to the chemical reaction, its properties will be changed. The same thing, if the transmission line face temperature and rain, cold, like the different environmental conditions, right? Due to this, the temperature that conductor forms a one layer on this, that is called as oxidation layer is called. It is called oxidation. Due to the layer, the pressure will be increasing in the conductor, and due to that, the performance of the conductor will be reduced. That is called as corona effect. So in that, you guys are known about how the corona will be happening in the transmission line, and what are the factors are affecting this loss and how we can minimize that. Next one is critical voltage and power loss. When the corona loss will be occurring in the transmission line, these losses will be occur. That is critical voltages and power loss will be occur. So these are the topics we are going to study in that third unit. Next one is radio interference. So what is the meaning of radio interference means? Suppose if the transmission line and one of the telephone line both are traveling the same parallel path. So at that time, the wavelength, the refraction, there is no refraction between these two different lines. So one is electrical supply, another one is TV signals, right? So if there is no linkage between, so if there is any connection between this, that is called as radio interference. Next one is sag. So how we can get sag and means, so this is the one of the most important topic in the third unit. So let me see that how the sag will be occur. Suppose if you these are the two towers, tower 1 and tower 2, and if you connect a conductor between the two towers, so if you observe this, the conductor should not connect tightly between the two towers. So it is always connected in the loose connection. It means that it is freely connected between these two towers. So why? Because this conductor should change its behavior based on the temperature and cold, right? So at that time, so if the temperature is more, this structure will be like this. I will die here. So when the temperature is facing, the structure will be like this. Now how we can find the sag of these lines means, so this is the distance between the two lines, and so the length of the midpoint of this is the lower end point. This distance is called as sag. So this type of calculations is needed in the transmission lines. So that is the elongate, the peak point of elongated transmission line to the midpoint of distance between this. The distance is called as sag and tension. So these are the topics we are going to study in this, that is sag and tension calculations. Next one is effect of wind and ice on weight of conductor. So this is one of the major problem we are facing in the transmission line system. So it means that, so that's why some areas where it is cool areas, so other conditions they are using the underground transmission system due to because of these two parameters. One is wind and ice. So when the wind is more, one of the two phases should be touch each other. then it makes a short circuit. So that is the major problem will be happening in the transmission line by the wind as well as ice. Next, stream chart and stack number. So this is the information you are going to know about how the transmission line should be facing the loss, how we can minimize the loss, and what are the precautions we have to take. Next, we go for next one. Right. So this is the look. It is all that is insulators. So the power supply is never connected directly to the tower. So it should be always connected to the insulator. This is brown color is called. This is the insulators we are using in the transmission system. So in this unit, you are going to know aware about how the insulator should be manufacturing. What are the different types of insulators we are using in the transmission? So if you are thinking that it is just a material, but there is some considerations while designing the insulators. It means that if you observe this, it is a disc type. So they are connecting a different number of discs to the single structure. So it means that how the disk will be, how the diameter of disk will be more based on the voltage level. So that are the calculations you are going to know in the third unit. So this is the calculation. So this is the internal structure of insulator. So this is the disk one. So this is the entire part is belongs to the disk one. So the calculation, the precautions, the remedy should be like this. So the lower end and upper end should be 120 millimeters. The distance between these two is 254 millimeters. So these are the standard parameters, and they are using the material that is galvanized steel for locking pin. So from here you are going to connect the conductor for transmitting the power. So you can't able to connect directly to this material. Why? Because it is a not non-aligned material. If it is connect directly, it will be burnt like this. And so these are the different materials we are using in the insulator. One is porcelain, galvanized steel, and cementing. So cementing properties we are using in this here. So this is the internal structure of an insulator. So this is called as disc insulator. So in mostly we are using in the transmission line, there are different types. One is a disc type, suspension type, pin type. So these are the different types of insulators you are going to study in the third unit. Next one is fourth unit. So the first three units, the first one is designing, next one is knowing the performance of a transmission line, third one is how we can maintain the mechanical support to the transmission line. So this three is over. Now we have to examine that what are the problems we are facing in the transmission lines while transferring the power from sending end to receiving end. So these are the topics we are, this is the fourth unit, shares that what are the problems we are facing that in transmission lines while sending the power from sending end to receiving end. The first one is types of system transient. So transients in the sense is, transient is, it is a disturbance with short time period, that is called as transients. So what are the different types of disturbances will be happening in the transmission system we are going to study about, and traveling and propagation of surges. It means that whether the sinusoidal waveform should be pure from the entire process or there is any deviation that you are going to study, that is called as surges. Next, attenuation and distortion. That is also disturbances happening in the transmission lines, and reflection and refraction coefficients. So these two should be depends on the lightning effects. So how the lightning effects will be facing the problem on the transmission lines, and you can get the idea about lightning effects by using this topic, that is reflection and refraction. Next, termination of lines with different types of conditions. Suppose if any one of the conductors should be failure, we have to replace that, that is terminated. So while terminating the conductor, what are the conditions you have to face? So if suppose if it is delta connection, right? If it is delta, in the delta one of the phase is damaged, you have to remove this. Then it will make the open circuited lines, right? Suppose if it is one of the new conductor is added, then it is called as short circuited. So these are the different conditions you are going to know about this. Next one is lumped reactive junctions. So lumped reactive junctions means suppose in the transmission lines in between some areas there is a compensating devices like capacitors, inductors, reactors like that. So what is the function of this device means it will be boost up the voltage if there is any disturbances occur in the transmission lines. So that is called as lumped reactive junction. Lumped means we can easily remove and we can easily insert in the transmission line. That is called as lumped. Next, Bailey's lattice diagram. It means that how the system performance before and after after rearranging of transmission lines. Suppose if the transmission is failure, the transmission line AR is failure, so we are going to replace this. So we have to examine that what is the performance before adding the new conductor after conductor. So that will show by the Bevel's lattice diagram. So for all cases mentioned with numerical example, so we have to calculate that each and every parameters like that. So the next one is different types of cables. So the unit 5 you are going to study about what are the different types of cables we are using in the transmission lines. So these are the types of cables and constructions, insulating materials. So if you guys have seen that this way, right? So if you observe that this way, in the top layer is black color, and in bit after that there is a one layer, then a metal layer. After that a small conductor is flowing that. So this is the main part, and the outer side is called as insulating materials, and this insulating materials will protect this small conductor, small wire, right? So that is called as cable. So cable is always made up of a protection layer. That protection layer is called as insulating materials. Now you have to find here, you are going to find that what is the resistance of insulating material, and it should be depends on that this middle point y. So how much of voltage it is carrying, based on that you can get the insulating material. Next, capacitance of single and three core belted cables. So if it is single wire, what is the insulation capacity? If it is three wires, what is the insulation capacity? And how we can calculate, that is numerical problems. And grading of cables. It means that based on the capacity of supply, the cable should be classified based on the how much of capacity it can be capable. And description of intersect grading. It means that if it is any deviation occur, how we can replace the cables. So these are the 5 units you are going to study in the electrical power transmission system. Now, see, while listening class, if you face any problem, is don't worry. So this entire class will be recorded. After recorded, I will send you this video link so you can get clarified. So I will send every material, every class PPT and video. You will send you. Okay, now, right? How we can get this this type of information is I will show you. So these are the 5 units you are going to study in this electrical power transmission system. So next what you guys are doing means, wait, I will show you one app. From that you can get that how we can calculate that value. See, I will show you that how we can get the materials, I am going to send. See, all of you, classroom app in your mobile. In that, you can get the all materials. How what are I'm going to send. That will you can access that. So in future, you can get access. You can download that from that material. You can get the information from that, right? So this is about overview on electrical power transmission system. Do you have any doubts on this? You can get clarified on this class. See, all of you just download that classroom app. Then I will tell you how we can access this all materials and videos, whatever it may be. I'm going to send to you. So wait for 5 minutes. I will show you how it will be. Right, no problem. So I will send you app link in WhatsApp group. Then you can get. After that, I will tell you that what are the procedure you can how we can access that files, right? So today class I'm going to end it up now. So if you have any problem.